Sorry for the short video on the last one. Let's start at 15 now. If we're going to write this in log form, that means we're going to have log base A of B equals some number, right? So that's the form that is logarithmic form. So what I'm going to do is, we know that the base number on the log has to be the base number on the exponent. So I'm going to say log base 5. The B comes from over here, of 25 is 2. If we're going to solve this, we need to have the base numbers being the same, so I'm going to write 32 as 2 to the 5th. Now that I have the base numbers the same, we're going to do log base 2 of both sides, which log base 2 of 2 to the power of goes away. Log base 2, 2 to the power of goes away. So I'm left with 5 equals 2x minus 5. 10 equals 2x. X must be 5. Initial deposit of $5,000 made in a savings account for which the interest is compounded continuously. If it's compounded continuously, we're using A equals PE to the RT. Let's find out how much money, what is the annual, let's find out the interest rate. We know that it is tripled in 12 years, so the amount that you get out would be $15,000. We started with 5,000. E to the interest rate is what we're looking for, but we know it was for 12 years. Let's divide both sides by 5,000 to start with. And I get 3 equals E to the 12R. I want to get rid of the E, so I'm going to ln both sides, because ln and E are opposite operations. I get the ln of 3. These are opposite, so they go away, and I get 12R, divide by 12, divide by 12. And so my R is the ln of 3 divided by 12. And I get that the interest rate must be 9.2%. Where's the horizontal asymptote for the graph? My horizontal asymptote would be, notice the line continues to get closer and closer and closer to the -5. And so we know the horizontal asymptote is at y equals -5. If we're going to condense this, we're going to put ln of x to the 1/3. Notice that the opposite operation of the exponent coming down is it going back up, plus ln of x plus 1, plus, again, the number out front goes up top, the ln of x minus 1 squared. In the log world, we are adding exponents when we multiply, so if I want to put this together, I can say x to the 1/3 times x plus 1 times x minus 1. We could put that together even further by foiling these things together, but I don't think that's what we're going after here. Discontinuity, what kind of discontinuity is this? Well, I know that there is a vertical asymptote at -5. So if I draw this in, I know that over here at -5, I'm going to have a vertical asymptote there. So if I wanted to find out what kind of discontinuity is, I want to need to know what's going on both sides of that. It's either going to be this one going up and this one going down, one going up and one going down, or both going the same direction. All right, to find that out, we're probably going to either want to graph it or on our graphing calculators, or we're going to want to find some points. I'm going to take some time here and put this on my calculator. All right, after I graphed it, I see that if I take the x out of the top, I get x squared plus 7x plus 10, and then the top factors into x plus 5, x plus 2. So the x plus 5 from the numerator and the x plus 5 from the denominator goes away. So when that goes away, we know that it's just a point discontinuity at -5, that it's not one going up and one going down. So this is a point discontinuity at that single point at -5. So this is a point discontinuity. Number 21, if we're going to find f plus g of x and f minus g of x, we're going to be writing 2x squared plus 7. That's your f of x. And then I'm going to add to that g of x, which is 7 minus x. Putting them together, I get 2x squared minus x plus 14 for my f plus g of x. And then the second one, if I'm going to do f minus g of x, I'm going to have 2x squared minus 7 minus the quantity of 7 minus x. So when I get rid of the parentheses, I get minus 7 and plus x. So I'm going to have 2x squared plus x minus 14. So this one is your f minus g of x. And this one's your f plus g of x. A right triangle has an acute angle theta such that the cosecant is 7/3. Find the tan. So we know that the cosecant is 1 over the sine. So I'm going to say that this is the same as my cosecant. Theta. And so I would say that my sine would be 1 over the 7/3. So we know that we would have the sine of theta would be 3/7. And so if I draw my triangle, the sine is the opposite over the hypotenuse. Here's our theta again. And if I use my Pythagorean theorem, I have 3 squared plus, let's put an x down there, equals 7 squared. I get 9 plus x squared equals 49. X squared must be 40. X must be 2 square roots of 10. If that is 2 square roots of 10, and they're asking us to find the tangent. Well, here's our theta. Tangent is opposite over adjacent. So my tan would be the opposite over the adjacent. And so we would do some rationalizing, and I would get 3 square roots of 10 over 20.